Welcome to the NUPOC video study guide number 95. Let's take a look at another fluids and buoyancy problem now. So in this problem we have a tank of water, and the tank has a diameter of 30 centimeters, and we have this cone with these dimensions here. It's 10 centimeters high and 12 centimeters across at the base, and it weighs 300 grams, and we want to know how much water we want to know how high the water level will rise. So it's a delta H here of the water, H2O. But to find that, we'll need to know how much water is displaced by this cone. And before we can do that, we want to find out, will this cone float or not? Alright, so first, to find out, will it float? Let's go ahead and find what the volume of this cone is, right? So, volume of a cone, if we recall, of course we could derive it using calculus and just integrating around a series of disks that are getting smaller and smaller and integrating it from, say, z equals 0 to z equals h. But let's just use the formula, since this is a problem focusing on fluids and buoyancy and not volumes by calculus. So the volume of a cone is 1/3 pi r squared h. Okay? So in our case, that's 1/3 pi. And let's just do everything in centimeters. So r squared is just 6 centimeters squared times h, which is 10 centimeters. And this comes out to 377 centimeters squared. Okay, so we know that water, right, H2O, or let's write it this way, the density of water, or rho H2O, we know is about 1 gram per cubic centimeter. And by the way, this obviously, we're doing volume, so I misspoke earlier. That's centimeters cubed, right? 377 centimeters cubed, or cubic centimeters, whatever we want to call it. So I could write it the other way here, 377 centimeters cubed, or cubic centimeters, right? And the density of water is 1 gram per cubic centimeter, and if we look at the density of the cone, it looks like we have 300 grams per 377 cubic centimeters. So that is less than 1 gram per cubic centimeter, so the cone floats. And so instead of displacing its entire volume in water, instead of displacing 377 cubic centimeters of water, if it were totally submerged, it will only displace 300 grams of water. But since water is 1 gram per cubic centimeter, we can just say it displaces, so it displaces 300 cubic centimeters of water, right? Okay, so now let's find out how much higher the water has to rise to accommodate an extra 300 cubic centimeters of water, right? So we know that the volume of a cylinder, right, just equals pi r squared h, right? And we know the additional volume of water that we need to contain in this cylinder. That's 300 cubic centimeters. So we can write 300, all right, I'm going to write it as cm cubed here now, because we're going to use square centimeters as well for the radius. So this equals pi, and then r is 15 cm we'll square that. And then our height, that's the delta H. That's the additional height that the water will rise to accommodate this 300 cubic centimeters. So if we go ahead and just divide both sides by pi times 15 centimeters squared, we get delta H equals 300 cm cubed over pi times 200 and, let's see, is that 225, I think? 200 and 225 cm squared, right? Okay. So the units check out. This is unitless. This is cm cubed, cm squared, so the units of this will be centimeters. And we get something like 0.4 centimeters is our delta H. So H2O rises 0.4 centimeters in the tank when cone is added. Okay, and of course, if the cone was more dense than water and it would sink, then it would displace its volume in water. So it would displace 377 cubic centimeters, and so we would have just used 377 right here instead of 300. And so it would increase the height of the water a little bit more than it does, which makes sense. Like if you have an object that floats, right, and then you force it underwater, right? You take it and you grab it and you pull it underwater like a ball or something, right? The water level goes up, right? So that's that difference in the amount of water it needs to displace to float and the amount of water it actually displaces if it's completely submerged. So thanks for watching, and as always, don't forget to click to subscribe so you don't miss out on any upcoming videos.